Alright, hello everyone, we're back with another video, and today we'll be diving deep into SAT geometry concepts. Thank you to PVWorks for this worksheet, and yeah, let's get started. Geometry is one of the trickiest subjects on the SAT math section, so I thought it'd be a good idea to just completely flesh out all the core concepts in this video. Alright, and we're going to do that with some practice problems. Alright, number 1. In the figure above, if AB is a line, what's the value of y? Okay. So they're telling us that AB is a line. Right? So that means this entire angle is 180 degrees. Which means 2x plus y is 180. And now, we also know that the sum of the angles around this point right here is 360. So how many x's do we have? 1, 2, 3, 4, 5, 6, 7. So 7x plus y is equal to 360. Now we could just subtract these two equations. You get negative 5x equals to negative 180, and then you get x is 36. So then what would y be? Well, 2 times x, which is 36, plus y is 180. Well, that means y equals 180 minus 2 times 36, or 108. That's our answer. Let's erase this work and go to question 2. Alright, in the figure above, AD, BE, and CF intersect at point O. If the measure of AOB is 80 and CF. Alright, so let's write this down one at a time. So we know this angle, AOB, is 80 degrees. And CF bisects BOD. So this angle BOD right here, we're told that this line CF splits the angle into two equal parts. I'm going to call these, if angle BOC is theta, then angle COD is also theta. And then we want the measure of EOF. So we want the measure of theta, because EOF is also theta because of the vertical angles theorem. Okay, so what can we tell from this equation? Well, 80 plus 2 theta is equal to 180, because 80 is a straight line, so you know theta is 50. And is that an answer choice? Yep, that is. Okay, next question. Let's see. Oh my god, let's see this. In the figure above, if x is 70 and y is 40, and the dotted lines bisect the angles with measures x and y, what's the value of z? Okay. So if this dotted line, if this line, if that line cuts x in half, then we know this part is x by 2 and this part is x by 2. Similarly, this part is y by 2 and this part is y by 2. But what do you know? X over 2 plus y over 2 is coincidentally equal to z. Now this is just x plus y divided by 2 that's equal to z. And what do we know x plus y is? X plus y is 110. So z is just 110 divided by 2, or 55. And we're done. Alright, number 4. What that is. In the figure above, y plus z equals what? Alright, we could just angle chase here. Since line n is a straight line, this angle right here will be 180 minus 115, that's 75. Right? And then this angle right here, that angle right there is 180 minus y. And then this angle is 180 minus z. Now what do we know about this angle, that angle, and this angle? Well, they're all angles of a triangle. So what does that mean? They should sum to 180 degrees. So if we add these three together, we get 360 plus 75 minus y minus z is equal to 180. Now what's 360 plus 75? Well, that's 435. 435 minus y minus z is equal to 180. So that means negative y minus z is equal to 180 minus 435, which is, let's see, 435 minus... Oh, this is not 75. Hold on. We made a slight calculation error, guys. Let's see. Gotta redo this. This angle is actually 65, not 75. This is still 180 minus y, and this is still 180 minus z. If we add them all together, now we get 425 minus y minus z is equal to 180. And if you solve this, you get y plus z is equal to 245. And that's E. And we're done, guys. Alright, number 5. In triangle ABC above, what's the value of x? Okay, so here we just apply something called the exterior angle theorem, right? So if you have a line that's extended from one of the sides of the triangle, the angle formed with that extended line and the closest side, which is BC, is equal to the sum of the two angles opposite this angle. So the two angles opposite this angle are that angle and that angle. So from this theorem, we know 25 plus x equals 60. So x is 35. Alright, we move on. Okay, number 6. If the length of a rectangle is increased by 30% and the width of the same rectangle is decreased by 30%, what's the effect on the area of the rectangle? Okay, say we have... Let's pick some nice numbers. Since everything is in percent, and we'll do it in 10. Okay, so assume that this side is 20 and that side is 10. So the area is 200, right? And what are they telling us? They're telling us if the length of the rectangle is increased by 30%, so 20 becomes 26, and then the width of the same rectangle is decreased by 30%, so 10 becomes 7, and then what's the area? We multiply, let's see. Okay, 26 times 7 to 418. So the area is now 182. Now we just need to know the percent change from 200 to 182. How do we do that? So we do 200 minus 182 divided by 200. This is just a 9% decrease. So E is our answer. Alright, number 7. What's the value of W? Okay. Alright, from the vertical angles theorem, we know this is 35, and that's 45. God, this writing so bad. We know this angle, that's 35, and then this angle, that's 45. And then we know the sum of the angles in this triangle is sum to 180. So 35 plus 45 plus W has to equal 180. Now what's 35 plus 45? Well, that's just equal to 80, right? So 80 plus W is 180, so W is 100. Alright, number 9. Sorry, not number 9. Number 8. Okay. In the figure above, line L is parallel to line M. If x is equal to 80 and y is equal to 70, what's the value of z? Okay. So x is equal to 80, they say. So then this will also be equal to x by vertical angles, and this will also be equal to y by vertical angles. And now we want the value of z. So x plus y plus z is equal to 180. Now what's x plus y? X plus y is 80 plus 70. That's 150. 150 plus z equals 180. So z equals 30. And we're done. Okay. Number 9. For triangles above, the perimeter of ABC equals the perimeter of DEF. If ABC is equilateral, what's the length of AB? Alright, an equal triangle means that all the sides are equal. They're the same. So we'll call that x. So we know the perimeter of ABC, which is 3x, is equal to 4 plus 8 plus 9. 4 plus 8 plus 9, that's just 21. And that's equal to 3x, so x is equal to 7. That's the length of AB. Number 10. A square and an equilateral triangle have equal perimeters. If the square has sides of length 3, what's the length of what side of the triangle? Okay, so we know we have a square with side length 3, and its perimeter is 12. Then we have an equilateral triangle with 3 equal sides of length x. So here we can solve the equation 12 equals 3x, and one side of the triangle is 4. And we're done with that question. Alright. In the figure above, the perimeter of the triangle is 4 plus 2 root 2. What's the value of x? Well, we want to calculate the hypotenuse as well in terms of x. So we have an equation for the perimeter all in terms of x, and then we can solve like that. Alright, so this is an isosceles right triangle, which means this is a 45, 45, 90 right triangle, which means this hypotenuse is x root 2. So now we have the equation 2x plus x root 2 is equal to 4 plus 2 root 2. Now it's easy to see here, where we can factor out a root 2. We can factor out an x. Let's factor out the x. X times 2 plus root 2 is equal to 4 plus 2 root 2. And then we can divide everything by 2 plus root 2. And we get x is equal to 2. That's A. Okay. So we're on to number 12. If the 5 line segments in the figure above are all congruent, what's the ratio of the length of AC, not shown, to the length of BD? So AC right there. Okay, we're told that all these segments are congruent. So 1, 2, 3, 4. All of them. And we want the ratio of the length BD, or ratio of the length of AC to BD. Okay. Let's see. Okay, so this is most likely a rhombus that we're given here. And we're told that BD is the same, right? And in a rhombus, the diagonals bisect each other. So we can do, I'm going to mark these segments, the same, right? Mark the segments the same. And remember, these lines are parallel, right? Which means if this angle is x, well, that angle will also be x, right? Well, 180 minus x. Okay, let's see. So I guess we can use the law of cosines. I think that's just like the fastest brute force way to do it. There's probably a better way, but we'll see. So x squared which is BD, is equal to 2x squared minus 2x squared times cosine of this angle. So cosine, here, let me clean this up a bit. Okay. So we're gonna use the law of cosines really quick, just to brute force this. So we know what we want: AC over BD. That's what we want. That's perfectly clear. That's what we want, right? But in order to find out what AC is, we need to know these angles, right? So I'm gonna first focus on finding these two angles right here. So if this angle is x, that angle is 180 minus x. Actually, let's label it the other way around. First, we want to find this angle. And then we want to find this angle, which is 180 minus x. Alright, so if we label all these sides y, that's what we're told anyway. BD is also y. Now, would you look at that? We don't even need to use the law of cosines. This is why, that's why, that's why. Look what we have here. We have an equilateral triangle, which means all these angles are 60 degrees. Right? And this triangle is also equilateral, which means what? All those angles are 60 degrees. 60, 60, 60. So all 60-degree angles. And now we want the ratio of AC over BD. Well, we know BD is y. So we just need to find what AC is. In terms of y. Now, how can we do that? Well, let's think about this. Right? We could use the law of cosines. So let's just try doing that really quickly. So let's see. We get AC squared is equal to y squared plus y squared, which is 2y squared, minus 2 times y, which is 2y, times cosine of 120. Now, what's the cosine of 120? This is 2y squared, by the way. Cosine of 120 is -1/2. So that part is just plus y squared. So AC squared is equal to 3y squared. That means AC is equal to root 3y. So AC over BD is root 3 to 1. That was a nice problem, and we'll move on. In this video, we'll be covering only the first 15 questions of this document compilation of SAT geometry problems, and then the next installment of this series, we'll be going over the next 15, and so on. Okay. Number 13. In the triangles above, what's the average of U, V, W, X, Y, Z? Or X and Y. Okay. Now this, they tell us that this is a right angle, which means what? X plus Y equals 90 degrees. Right. And U, V, W are all angles of a triangle, so their sum, U, V, W, be 180. So their average, which is U plus V plus W, X, Y, all divided by 5, will be just equal to 90 plus 180 divided by 5. which is equal to 18 plus 36, which is equal to 54, and that's E. Okay, number 14, the perimeter of equilateral triangle ABC is 3 times the perimeter of equilateral triangle DEF. If the perimeter of DEF is 10, what's the length of one side of ABC? Alright, so we have that, and then we have this. This is ABC, this is DEF. Alright, so if the perimeter of DEF is 10, one side is 10 over 3. Now, if the perimeter of triangle ABC is 3 times that, well, their side lengths will also be 3 times the side lengths of DEF. And since DEF has a side length of 10 over 3, ABC will have a side length of 10, which is 3 times that. So that's our answer. Alright, number 15. If the 5 line segments in the above figure are all congruent, what is the length of AC not shown to the length of BD? Oh, well, we just did that. I guess they repeated a problem for extra practice, but we already did that. We know what that is. Just root 3 to 1. Right? Right, we also did that question. Well, I wasn't kind of finished, so I'll do one more actual new question. And we'll be done. Okay, number 17. In the figure above, points P, A, and B are all equally spaced on line L, and points P, Q, and R are all equally spaced on line M. If PB is 4, so that means PA is 2, AB is 2. That's what it means if 3 points on a line are all equally spaced. The gaps between the 3 points will all be the same. And PR is 6, so that means PQ is 3, that is 3. And AQ is 4. What is the perimeter of quadrilateral QABR? Okay, we know 3 sides of quadrilateral QABR. We know AB, we know AQ, we know QR. We just need to find out what BR is. And you know how we're going to do that? We're going to use similar triangles. Alright, both triangles PAQ and triangles PBR share angle P. So they have an angle congruent. And the ratios of the sides tangent to that angle, so that would be 2 over 4 is equivalent to 3 over 6. So the two triangles are similar by SAS similarity. And their similarity ratio is 1 to 2 from small to big. So this side is 4, that side is 8. Now we can find the perimeter of the quadrilateral. That's just 8 plus 3 plus 4 plus 2, which is 11 plus 6, which is 17. That's E. And we'll do this one last problem, and then we'll be done for this video. Okay, in the figure above, what is the value of PT over PS? Okay. So what is the relationship here? So you want PT over PS, right? Both this triangle and that triangle share angle P, and they also have another congruent angle. So by AAA similarity, we have triangle PQT similar to triangle PRS. And so we know the ratio PT to PS will be equal to QT over RS. Now QT and RS, we know what they are. That'll just be equal to 8 over 10, which is 4 over 5. And what answer? Choice is that? That's E. And we're done for this video. Alright guys, that's it for this part of the SAT Geometry series. Stay tuned for the next installment. It'll be coming very, very soon. And yeah, if you found this video useful, and you know people who will find this video useful, please share it to them, and don't forget to like, subscribe, and leave your thoughts down below. And I'll see you